Hey guys, it's Alex from EDD Academy, but before I get into this quotient rule video, I want to say something. So, it feels super weird for me to announce my name as Alex in every single video because I literally haven't been called that in years, and I go by Shved in real life. So, quick note, from now on, I'm Shved. That's it. Similarly to the product rule that we learned in last video, the quotient rule takes two differentiable functions, f of x and g of x, and basically computes the derivative of their quotient. So the derivative ddx of f of x over g of x. And basically what the quotient rule says is we have g of x times the derivative of f prime of x, or times the derivative of f of x, which is f prime of x, minus f of x times the derivative of g prime of x, all over g of x quantity squared. Often, this is pretty confusable, and I mean, look at it. There are so many terms and it's like all over the place. So how it's taught in math classes, how people remember it is low d high minus high d low all over low squared. Basically, the bottom term times the derivative of the top term minus the top term times the derivative of the low term all over the low term squared. So our first example reads, find the derivative of x over 2x minus 4. Clearly, this is asking us to find the derivative of the form the quotient, or f of x over g of x, like we saw in the last example. So, we can basically apply the rule we learned here to our current question, and we get that the derivative f prime of x equals 2x minus 4 times the derivative of x low d high minus x times the derivative of 2x minus 4 all over 2x minus 4 squared. Low d high minus high d low all over low squared. If we simplify this out, we have 2x minus 4 times the derivative of x, which is 1, minus x times the derivative of 2x minus 4, which is, so x times 2, and then we still have all over 2x minus 4 squared. So a common mistake I see here would be trying to cancel this 2x minus 4 and this 2x minus 4 quantity squared on the bottom, but note, this 2x minus 4 is connected with a subtraction symbol, so you cannot do that. Instead, you can simplify this to 2x minus 4 minus 2x all over 2x minus 4 squared, and these two cancel, so we get that 4, or excuse me, negative 4 over 2x minus 4 squared is our derivative. So this is the final example of the video, example 2, and it asks us to find dy dx if y equals e to the x over 1 plus x squared. Clearly, this is the derivative of a quotient, e of e to the x over 1 plus x squared, so we use the quotient rule. I want to show a different approach to solving this problem though, one that I personally use all the time to make quotient rule derivatives a lot easier. Before I actually write out the quotient rule, I like determining what f of x and f prime of x are, as well as g of x and g prime of x, so I can avoid some of those intermediate computations and it's just a straightforward problem. So here, f of x equals e to the x, and f prime of x, as we learned in our exponential video, the derivative of e to the x is uniquely e to the x. And the bottom, g of x is just 1 plus x squared, and g prime of x is the derivative of this, which is 2x. So if we rewrite our quotient rule, dy dx equals 1 plus x squared times, and instead of writing d dx of e to the x, we can just write e to the x, and minus e to the x times 2x, all over 1 plus x squared quantity squared. Do not forget to square this low term. And once again, this fits the low d high minus high d low, all over low squared. If we simplify this statement, we have, let's see, distributing this, e to the x times 1 minus x squared, all over 1 plus x squared quantity squared. That is our derivative. Thanks for watching, guys. In the next video, I think we're going to be taking a look at our last example, or our last video for Chapter 2, and stay tuned for that.